All right, we're going to do a little study group for our retest tomorrow. I'm going to go over questions from the corrective. You guys should have already filled out the form, letting me know which questions you guys want to see. And some of these numbers over on the side, those are how many people wanted to see those questions. So I might just go ahead and do some of the problems that people didn't have, because I think this is short enough that we can kind of get through all of it, not take too long. I'm going to do a separate video for questions from the original exam after this. And, you're welcome to fast forward through questions that you don't have questions about. Find the area of the region, shaded region. Now, it's not actually shaded, but this would be it. And dx means we're going to do vertical slicing. We're going to integrate in with respect to x. And so you could draw, one of those slices, and it would be y top minus y bottom. And so the area is going to be the integral. I guess we need to stop for a second. We need to find these intersections. This appears to be at 0, 0. We might be able to confirm that. This one I'm not sure about. We could try and do it by hand by setting these equations equal to each other. You do have a calculator, so you could use your calculator to solve this. Now, I think this one might be easy enough to do by hand. If you add x to both sides, you get minus 3x equals 0. You're going to factor this, x minus 3, x equals 0, x equals 3, so 0, 0. And this one's at 3, negative 3. Now, if you plug 3 into this, you should get negative 3. If you plug 3 into this, you should get negative 3. 9 squared minus 12 is negative 3, so that's good. So we want to focus on the x coordinates. If we're integrating the x direction, 0 to 3. Y top, in terms of x, is the line, negative x. Don't mix them up. Y bottom is the parabola. You want to put that in parentheses. And then parentheses around the whole thing. And then you got to put the dx. And this would be good enough for your setup. If you're going to integrate it by hand, you probably want to distribute that and simplify things. But you could put this in your calculator. I mean, if you want, you could clean this up. 0 to 3. You could put negative x squared plus 4x, so it'd be plus 3x. So that's a little cleaner version. And if you're going to work it out by hand, that would probably be a good idea. So on our calculator, we're going to do math 9, negative x squared plus 3x, or you could type in the other version, comma x, comma 0, comma 3, hit enter, and we get a really nice answer, 4.5. Now, that's what you'd put right here, 4.5. We could show 3 decimal accuracy. You show the setup in the answer column. So there you go. No one asked about that one, but just thought I'd do it. Now, dy, we got to do horizontal slices. Now, that's challenging for a couple different reasons. I think some people just have trouble with it. X right minus x left. And we're gonna integrate. Now, here's the deal. At y equals negative 3, x right changes. X left is the same. So we're going to have to break this up and do 2 separate integrals. So we're going to have to do, now, I guess another challenge is we've got to figure out what the y coordinate of that is. Now, this is a parabola. Its x intercepts are going to be at 4 and 0, 0. And the axis symmetry and the vertex would be exactly halfway between those. So that's going to happen at 2. So if you plug 2 into your parabola, you get 4 minus 8 is negative 4. So, or you could use your calculator and find the min of that graph if you want to go ahead and bother graphing it and whatever. But we definitely need that. So we're going to have to do one integral where we do negative 4 to negative 3. And then we're going to have to do another integral from -3 to 0. So that's part of the challenge, realizing that you got to break it up and realizing what the limits are going to be when you break it up. Now we got to find these x right, x lefts in terms of y. So this is that line. So x right equals -y. So that's going to be x right from -3 to 0. X left, we have to solve this equation for x in terms of y. Now, I kind of made this problem a little mean, because to be able to solve for x, you would have to complete the square, which is something you guys should know how to do, but that's where you add the perfect number to both sides to complete the square. So it's always going to be half the middle term divided by 2 squared. So -4/2 is -2 squared is 4. We got to add a 4 to the other side. That allows us to write this as y plus 4 equals x minus 2 squared. So we're completing square by making the right side a perfect binomial squared. Then you take the square root of both sides, plus or minus. We're actually going to use both. The plus is going to be the right side of the parabola. The negative is going to be the left side of the parabola. And we're going to end up using both of them. So, and then we got to subtract 4. So x right over here is the positive square root of y plus 4 plus 2, because here the square root and the squared cancel. And then you got to add the 2 to get the x by itself. And over here, x left for both of these is going to be the negative square root of y plus 4 plus 2. And this one's going to be the negative square root of y plus 4 plus 2. So, yeah, I'm not going to do that on the retest, but yeah, it's just some good algebra review. So the first chunk, I'm starting from the bottom and going up usually when I think of in the y direction. So the first chunk is this bottom chunk, and x right is the positive square root of y plus 4 minus or plus 2. And then the next chunk that you got to subtract is the negative square root of y plus 4 plus 2 dy. And then the next part, x right is negative y, and x left is negative square root of y plus 4 plus 2. You got to put parentheses around it, or at least distribute that negative. This would be fine for the setup for me. You could clean it up if you want. I'll write a slightly cleaner version over here. It would be -4 to -3. Distribute this negative, you would get 2 square root y plus 4 plus 2 minus 2. Those would cancel each other out. So the first one becomes that. And then the next one, -3 to 0. If you distribute this, that would be minus y plus the square root of y plus 4 minus 2 dy. So it's slightly cleaned up. And then you can enter in your calculator. Now, when you enter your calculator, you're going to put x's for all the y's. So you're going to say math 9, and you're going to say 2 square root of x plus 4, close parentheses, comma x, comma -4, comma -3, close that. And then we could do the next one, plus math 9. Lights, weird glare there. I'll move it so you can see it. Negative x plus the square root of x plus 4, close parentheses and square root, minus 2, comma x, comma -3, comma 0. Now we should get the same answer as we got for the last part. So we should get 4.5 like we just got on the last problem. And we get 4.500 to 3 decimals. Not perfectly. When we did it with vertical, it was 4.5 exactly. In this one, we get some other numbers down here because your calculator is not actually integrating. It's slicing it and getting estimates, really good ones. 3 decimal actually rounded truncates the same. So that's number 1, 2 different ways. Number 2 says find k such that the vertical line x equals k splits the enclosed area into 2 equal parts. So that's talking about this problem up here still. So x equals k splits the enclosed area into two equal parts. So we're looking for a line x equals k that cuts that area in half. And this was something similar to the problem you had to do in the original test, and we'll have to do in the retest. So what we do is we say, well, if we can do a vertical line that cuts it, we have to use the vertical area setup. So the area, we want two equal parts. So we want 1/2 of the area that we got, which was 4.500, and maybe we should carry some extra decimal places because it's in the middle of our work, so we should round and truncate to 3 decimals in the middle of our work. And then we're going to integrate this from 0 to k. You could do k to 4, but 0 to k, or k to 3, but I would do 0 to k. I think that's going to be easier. And you have to use the vertical slicing setup. And so we're going to get 2.25000. And over here, we integrate it. So we get negative x cubed over 3 plus 3x squared over 2. And this is a definite integral, so we have to plug the limits in still. And so we plug k in first, and then plug k in. And then we plug 0 in and subtract it. Now be careful, just because when you plug 0 in, a lot of times it goes away. That's not always the case. So you got to be careful. Now this is an equation that we need to solve. And the way I would do it is I'm going to use my calculator, because I don't think we're going to, we could try rational root theorem and all that stuff, but why? We have a calculator. So I'm going to move everything on one side. Whichever side you want to. I'm going to just move everything to the left-hand side. That'll give me a positive first term equal to 0. So that's like your setup. That's kind of what I'm thinking for the setup here. And so then we're going to solve this on our calculator. So the way I solve these on my calculator is I go to y equals, and I type that in, x cubed divided by 3 minus 3x squared divided by 2 plus 2.25. You can put the zeros in if you want. And then I'm going to go to window, and I want to say, well, what k values are possible? And so it's 0 to 3, because those are the left and right sides of that region in terms of x is 0 to 3. So it's got to be somewhere in between those. And then all I care about is finding the x-intercept of this graph, because that's going to show me where equals 0 will be the solution. So I don't need to see the whole graph. Now I should just get one answer, and it looks like it's really close to middle. Don't assume that's 1.5. Do second calculate 0, and you tell it where you want to look for it, between 1 and 2, and I'm going to guess 1.5. And wow, it is actually perfectly 1.5. So k equals 1.500. Okay. Now y equals k is going to split it this way. Now this is a little more complicated because there's two different regions. We know that half the area, it's the same area. And we're going to set something up now. I think what we should do is let's first of all confirm if this area right here is more or less than half the area, because then we could decide if it's in this region or that region. We can narrow it down, because that's going to make things a lot easier, because we really want to just do one region or the other. So go back to the home screen, and I already deleted my previous calculations, but there's a quick way to bring it back up. Second enter. This is the one that we used to calculate that. And I want to know, so second enter copies and pastes the last command, and you can go back even more. I'm going to delete the second chunk that we calculated and just calculate that first chunk and see if it's what it is. That's that piece right there, 1.33. So that's less than half the area. So it's definitely going to be in this region. So now I'm going to go k to 0 because I want to work from k to 0. And plus, I'd rather use 0 anyways, but we're starting at k, which is below 0. You got to go bottom to top, k to 0. And it was this one right here, negative y minus this, or plus the square root of y plus 4 minus 2 dy. Then we got to integrate this. So negative y squared over 2 plus, this is to the 1/2, y plus 4, all in parentheses, to the 3/2, divide by the new exponent, minus 2y, and it's k to 0. So if we plug 0 in, we get, now I tell you all the time, if you plug 0 in, you get 0 here, plus 2/3. When you plug 0 in here, you actually get 4 to the 3/2 left, minus 0. So just because we're plugging in 0 doesn't mean, oh, it's always going to go away. It's usually simpler. Then we're going to plug k in, negative k squared over 2 plus 2/3 k plus 4 to the 3/2 minus 2k. So this is what we're going to try and solve on our calculator. Now I'm going to move everything to one side. You have to distribute this subtraction. You always got to do top limit in first, bottom limit in second. So I'll just move everything to that side. So we have, now by the way, 4 to 3/2, that's the square root of 4 is 2, cubed is 8, times 2 is 16. That's 16/3 plus k squared over 2 minus 2/3 k plus 4 to the 3/2 plus 2k minus 2.250000 equals 0. So that's kind of a crazy one, but we'll put that in our calculator. Put it in the y menu. We're going to enter all this in. 16/3 plus x squared. 16/3 plus x squared divided by 2 minus parentheses 2/3 parentheses x plus 4 raised to the parentheses 3/2. You need parentheses around the 3/2. Got to ensure order of operations, plus 2x minus 2.25000. We're going to go to window. We've got to change. Now the x values are the k values we're looking for. We expect it to be between -3 and 0. -3 and 0 are the y values that k might be. And you're like, oh, we're putting my x here. Okay, but remember k is, those are y values. We put them in as x's though. And then -1 to 1. So I'm going to graph this. I think we should really only get one answer. And there it is right there, which kind of makes sense that it's kind of lower in this region because there already a bunch of that area got added to count towards half the area. Second, calculate 0. It's between -3 and -2. I'm going to guess -2.5. And k equals -2.5095. We want 3 decimal accuracy, rounded or truncated, so -2.509 truncated, which is my favorite. It's harder to mess up truncation, but you could round it, and you would get that. So, okay. Well, those are definitely really challenging problems, so that's some good practice getting you ready for that. Okay, the base of the solid is bounded by y equals x4, y equals x4, and then there's a parabola here, y equals x squared. The intersections have been given to us, so it's one thing we don't have to do this time, but we could. This is the cross section, square minus half of a circle. Find the volume of the solid cross sections perpendicular to the axes. So let's draw one of those slices. One slice, and so we want to find that area times the thickness to get the volume of each slice and then integrate them all. Side, 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 side. The radius is side over 2. I want to use side because that's right here. That's x. That's y top minus y bottom. You always want your dimensions for your shape to be determined by the bottom of the slice touching the base region. So my volume is, some area in terms of x. It's specifically a square minus half of a circle. It's going to be side squared minus 1/2 pi r squared dx. We're integrating in the x direction, 0 to 4. The side is y top minus y bottom. Y top is 4x minus x squared minus pi over 2 4x minus x squared divided by 2 before you square it. People forgot that, dx. So this could be good enough for your setup. There are ways that we could write that cleaner if you want. I don't need that. If you were to write it cleaner, one, you could square this and bring it out here and write pi over 8 instead. And then you could even factor the 4x minus x squared 4x minus x squared out, and there'd be a 1 left minus pi over 8. Those are just constants, so you could bring those out of the integral and in front, and then you could write it as nicely as this, which could be worth it. Even if you're going to type in your calculator, it's just a lot less stuff to type in. So if we're going to enter this in our calculator, at least this one, you could do this other one if you want. Either way, 1 minus pi over 8. You got to put that in parentheses. Math 9, parentheses, 4x minus x squared, close parentheses squared. Don't forget that. Comma x, comma 0, comma 4. And our answer is 20.729. Rounded or truncated, it's the same this time. So the setup is all this stuff that you would put. So I'd like to see that in the answer column in whatever version you wanted to put there. But you need parentheses around everything. You need the dx. There were people I were taking points off for on their tests for just sloppy stuff, not putting parentheses around everything, not putting dx. Okay, B, set up an integral to determine the volume of the solid if the cross sections are perpendicular to the y-axis. So that's going to be like this. Same shape, unless I tell you a different shape. And so you have side, 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 side. Radius is half of a side. The side is x right minus x left. I write all over these pictures. X right minus x left. It's going to give a different volume. It creates a different shape. So this is not an option of doing one or the other like for area. The volume is going to be some area for the slices in terms of y, dy. It's a square minus half a circle. It's going to be side squared minus 1/2 pi r squared dy. You don't have to do that stuff. I just find it helpful to kind of get my brain going. So the sides are, now we got to get x right in terms of y. So x, you take the square root of both sides, plus or minus. We're dealing with the right half of the parabola, so we're dealing with the positive. And then over here, x equals y over 4. That's x left. So those are our two equations. So it's going to be parentheses and then more parentheses. You got to make sure you're doing top minus bottom or right minus left. So it's going to be positive square root of y minus y over 4 squared minus pi over 2 square root of y minus y over 4 all divided by 2 squared. And you could just square that and bring it out front if you want. Close the parentheses, dy. The limits are in the y direction. Bottom top, 0 to 16. If you put that in your calculator, you're going to get a different answer than the other one. Now, some of these I don't ask you. I just ask you for the setup. And some of them I ask you for the equals. What's the answer? So that's volume by cross-section, vertical slices, horizontal slices. And then we got a bunch of solids of revolution. So the answers and work for these are online in the shared folder. Okay, so these are all solids of revolution. We're going to do them two ways, dx and dy. One way will give us discs or washers, and the other way will give us shells. They should give you the same area. If you're to calculate them, all I'm doing on this page is setting them up. If you want, you could put both part A and B in your calculator, and they should give you the same number. If they don't, you either set one up wrong or both wrong, or you enter in your calculator wrong. But it is a good way to check your answer if you want. Okay, I'd probably draw separate pictures for each of these setups just because it gets a little busy. Now we're revolving around x equals 6. So I want to draw the other half. We also want all the intersections of this, which have already been kind of given to us. So I draw the other half, and dx has to be vertical slices. So you're going to draw a vertical slice. Vertical slice. You're going to draw the other one on the other half. And these are going to be shells. Anytime you slice parallel to the axis of rotation, you're going to get shells. And the volume for a shell, remember, if you take this piece of paper and you make a tube, that's a shell. If you cut it open, it's a rectangle. The height of the rectangle is the height of the shell. The other dimension of the rectangle is the circumference, 2 pi r of the shell. So it's going to be 2 pi r h, and the thickness is going to be dx. So that's your general setup. Don't memorize that. And then we're going to integrate it. And we're going to integrate in the x direction. Always use the original region for all your dimensions, all your limits. So we're going 0 to 4. The radius is there. This is the height. Now remember, the radius of shells doesn't depend on the curves. It just depends on whatever slice we're at. So it's going to be, in this case, x right minus x left, x right minus x left. And x right is always 6, and x left is whatever x value we're at. So the r is 6 minus x. The height is y top minus y bottom, and that's the one that really depends on the curves. So the height is the thing on shells that uses those equations, those curves. So y top is square root of x in terms of x. Y bottom is 0. dx, that's your setup for the shells. The next one, I'm going to try and redraw the picture on your tests, your retests. You'll have a lot more space to do this, but I think I can pull this off. I'm just going to make it a little smaller. This is x equals 6. That's 0, 0, 4, 0, 4, 2, y equals the square root of x. That's your original region. You're spinning it about. X equals 6. So even though this takes an extra minute or so, I think it's worth it. Now we're going to do horizontal slices. So that means they're going to be flat and they're going to be perpendicular to the axis of rotation. So you should know that that's going to give you discs or washers. Okay. So the volume of one of these discs is just a circle times the thickness, dy. So that shouldn't be something to memorize. It's gonna be pi big R squared dy minus pi little r squared dy, and then we're going to integrate them. So your big R is there, and then your little r is there. Always use the original region, okay? So the first, we're integrating in the y direction, so 0 to 2, bottom to top. The big R is x right minus x left. X right is always 6. X left is actually tied to the curve, and it is y squared, right? So 6 minus y squared, squared dy. Now, inside here, the little radius is x right minus x left. X right is always 6. X left is always 4. The radius is always 2 dy. And that makes sense because if you visualize what that volume is that we're subtracting right there, it's a perfect cylinder with a constant radius. So there you go. The next one, let's see, go like that. So part A is dx. So that's vertical slices. And they're going to be perpendicular to the axis of rotation, so they're going to give you disc washers. This is original region that you want to use for all your limits and your dimensions. So let's see. We have big R and we have little r. Now, big R is y top minus y bottom. And little r is also y top minus y bottom, but the y top is this bottom curve right here. And so the volume is going to be pi big R squared dx minus pi little r squared dx. And we're going to integrate them. And so we're integrating the x direction, 0 to 1, left to right. Big R, y top, is the square root of x. Y bottom is negative 2. So you got to subtract negative 2. Plus pi, 0 to 1. I'm sorry, minus, because we're taking that whole out. Y top right here is along that parabola. That's x squared minus y bottom is negative 2. So that's the disc wash method, dx. I'm going to redraw the picture. I don't know. I think it's worth it. Okay. So let's see. We'll crank this out real quick. 0, 0, 1, 1. This is y equals x squared. This is y equals the square root of x. This is the original region. We're spinning it around. Y equals negative 2. So I'm going to draw the other half down here. And this other half is really just to kind of help us visualize it. But this time we're slicing horizontally dy and dy. So those are going to be flat. They're going to be parallel to the axis of rotation. So they're going to give us shells. You really should know what you're expecting. Shells are dishwashers. This is the height and this is the radius. Now the volume of one of these, if you make your paper into a tube and you slice it open, it's a big rectangle. And like I drew up here, 2 pi r times h. 2 pi r h dy. And then we're going to integrate it. So okay, so we're integrating in the y direction, 0 to 1. Don't integrate from the axis rotation. The limits are always based off the original region. The radius is y top minus y bottom. And y top is whatever y value you're at. Y bottom is negative 2. So that's going to be y plus 2. The height is the thing that depends on the curves, x right minus x left in terms of y. So we got to take the square root of both sides of here, plus or minus. It's the right half parabola. So this x right is the positive square root of y. And over here, to get x in terms of y, we're going to get x equals y squared. So x right is the positive square root of y minus y squared dy. And that's the setup for that. Okay, now no one had questions on 4 or 5, but whatever, I just did them. You can skip them if you want. Now, a bunch of people had questions on 6 or 7, 6 and 7. So let's do those. This is 0, 6. It's the y-intercept of that line, right? This is 0, 0. We have the intersection here. This is the original region. We're spinning around the x-axis. So I like to draw the corners. Now, if we do dx, those are going to be vertical slices. The perpendicular axis is symmetry. You get disk washers. And so the volume is going to be pi r squared dx and minus pi little r squared dx. And so this is our big radius, and this is our little radius right here. They're both y top minus y bottom. Y top minus y bottom, different y tops and y bottoms potentially. We're integrating in the x direction, so 0 to 3. Y top is x plus 6. Y bottom is 0. Minus pi 0 to 3. Y top of the little radius is that parabola x squared minus y bottom is 0. And so that's your setup for disk washers. So I'm going to redraw the picture real quick. See how quickly I can do this. But I think it's worth it. Okay. So this is y equals x plus 6, 3, 9. This is 0, 0. This is 0, 6. This is the original region. This is y equals x squared. We're going to slice it horizontally. So horizontal slices are going to be parallel to the axis of rotation, and they're going to give you shells. Now, the thing you got to realize is that once you get past this point, the height of the shells is going to change. So we're going to have to do 2 different sets of shells to get this right. The radius of the shells is going to be pretty much set up the same way. It's y top minus y bottom. Y top minus y bottom. This is the height. Now the height is the thing that's going to change. It's x right minus x left. And this is the height, x right minus x left. And so our volume is 2 pi r h dy. And we're going to have to go 0 to 6 one way. And then plus, we're adding these, another one from 6 to 9, 2 pi r h dy differently. So the first one's 2 pi 0 to 6. The first one, 0 to 6, the r value is just going to be whatever y value you're at minus the center 0. So the r value is just y. The height, x right minus x left. So we got to get this x right here in terms of y, which would be plus or minus the square root of y. It's going to be the positive because it's the right half of the parabola. X left is 0. So it's going to be positive square root of y minus 0 dy plus 2 pi 6 to 9, different limits. X right is still the radius is still y top minus bottom. It's the y value you're at minus 0. It's still y. X right is still positive square root of y minus, now x left over here is going to be y minus 6. Get a solve for x, y minus 6. put it in parentheses, y minus 6 in parentheses dy. And so that's your setup for that one. And the last one, which kind of reminds me a little bit of the challenge problem on the original test, it says find the value of k if the solid formed has a volume. So they're giving you the volume. They're showing you that it's being revolved around this. So I'm going to draw the picture. Y equals k is this line. This is y equals the square root of x. We got to figure out what the limits of our shape are going to be. This is the original region, so we've got to find all the corners. Now, if this is y equals k, then that's the y coordinate. So this is going to be 0k. This one is going to be when those equal each other, right? Isn't that how we find the intersection of two curves? Is we set their y values equal to each other. And then we get x equals k squared. So the x coordinate right here is k squared. The y coordinate is k. So it's going to depend on how you want to slice this. We could probably do it either way with dishwashers or shells. Now, we want to set this up to find the volume and set it equal to the volume they gave us. So if we do vertical slices, I'm going to try and squeeze both of these in on the same picture. You don't have to do them both, so you're probably just going to do one. If we do vertical slices, it's going to be parallel to the axis of rotation. So those are going to be shells. And we get R and we get H, and H is y top minus y bottom. And R is x right minus x left. And the volume would be 2 pi RH dx. And it's going to equal 32 pi over 5. And so the limits are going to be in the x direction, 0 to k squared. You need that x coordinate. You got to find that intersection point. The radius is whatever x value we're at minus 0, which is 0. The height is going to be y top, which is k all the time, minus y bottom, which is the square root of x dx. And that's supposed to equal 32 pi over 5. Okay, well, we got to integrate this. This is a lot like finding that y equals k or x equals k that cuts the area in half problem on the front. So we're going to have to actually integrate this by hand. And so we probably want to simplify this and say, well, this is kx minus x to the, we're distributing this, x to the 3 halves. And then we're going to integrate it, 2 pi, so it's going to be k. The k is just a number, x squared over 2 minus x to the 5 halves divided by the new exponent, 2/5, 0 to k squared. Now, if you want right now, we could divide a pi out of both sides. So we divided 2 out of both sides. That just makes things a little cleaner. We got to plug this limit in. Top limit in first, bottom limit in second. So this is going to be k squared gets plugged in here, gets squared to k to 4. This is k to the 5th over 2 minus 2/5. And it's going to be k squared to the 5 halves equals 16/5. Now, you're going to take the square root of k squared, which is k, raised to the 5th power. So this is k to the 5th over 2 minus 2/5 k to the 5th. And then we could group these together because they're like terms. So we give them least common denominator 10. And so that gives you 5k squared minus 4k squared is 1k, or 5k to the 5th minus 4k to the 5th is 1k to the 5th over 10 equals 16/5. And you don't need a calculator for this. You can multiply both sides by 10. And that gives you k to the 5th equals 32. And then you're going to take the 5th root of both sides, no plus or minus, it's an odd root. And you get the answer is k equals 2. So it works out really nice without a calculator if you've set it up correctly. The other way you could have done it, so that's one way. The other way you could have done it was with horizontal slices, which would give you discs. And so the volume, it's not a washer, pi r squared dy. And that would be, we're going in the y direction, 0 to k. Now the radius is x right minus x left. And x right equals y squared. And x left equals 0. So it's going to be y squared squared dy. And it should equal 32 pi over 5. This is, even though we're having to do y here, it looks a lot easier than the other way we just got done doing it. So it's going to be pi 0 to k of y to the 4th dy equals 32 pi over 5. We could divide the pi out of both sides. The antiderivative here is y to the 5th over 5. Still got to plug in the limits. And so if you plug the limits, you get k to the 5th over 5 minus 0 over 5 equals 32 over 5. That goes away. We can multiply both sides by 5 and then take the 5th root of both sides. And we get k equals 2. So same answer, should be the same. So that's it for the corrective. I'm going to go ahead and make a second video with test questions.